So I still get a little bit freaked out by this. I'm not sure if you see, but they're a bit big, these pictures. But anyway, so my name's John Bloomfield. I'm part of the DSS team. One of the things is, the standards team is made up of lots of different parts, but today, what we're going to be doing, we're going to be discussing infrastructure as code and how it relates to PCI DSS. I've got Peter O'Sullivan with me today. So as I said, infrastructure as code in the context of PCI DSS.
I'm Peter O'Sullivan. I'm a QSA and a 3DS QSA at Blackfoot Cybersecurity. I'll be focusing on how IAC can be implemented in real-world scenarios alongside DSS controls, which will ensure the security of your cardholder data. And I'll be providing practical approaches on how assessors can validate where IAC is deployed.
Okay, bit of a quick recap here. So PCI DSS, now what we've got here, this is really setting the requirements that's going to be needed to be, it's protecting that account data, within an environment that is storing, processing or transmitting that data, or potentially could impact the security of that CDE.
Now, IAC's using tools to manage cloud-based computing and network infrastructure using machine-readable code, the IAC documents themselves, which applies often to one or more virtual services or virtual devices which operate in the cloud. Integrating those types of environments with PCI DSS really helps organizations to automate their infrastructure management, which allows that greater consistency and control, which aligns really well with the tenets of PCI DSS.
Okay, what we've just got here, I'll just step over just to this side, we've got some of the differences between that kind of traditional infrastructure and infrastructure as code. So with that traditional infrastructure, you've got the hardware configs, they're typically being, updated manually. People will be going to each of those devices. Often it's done individually. Now, the issue that we have here is that when you're doing those updates, having to do it time and time again, it's not really going to be very scalable. And also there's a really high chance of misconfigurations.
IAC, however, has got distinct advantages at this point. You're using those code documents and using the tools that are alongside with it, which manage this infrastructure by sort of having you create those documents once and maintaining them, modifying them, keeping them alive, and then processing them many, many times. That's going to give you consistency, repeatability, and that automation with your infrastructure management. And those documents illustrate how you can streamline that infrastructure management while giving you enhancement in your security and compliance efforts.
Okay, so what we've just got here is basically what we've just been talking about on that last slide. So, we might have a network engineer, we'd have that kind of configuration file, and then obviously just updating it to a component.
Now, conversely, what we have here is your engineer authoring their infrastructure as code documentation, which is generally going to get stored in a distributed version control system, which we all know as a repo. Something like Git, GitHub, Bitbucket, those things. Now, there's likely to then be some sort of processing engine. We're calling it the engine just because they can vary. And that will be connected to those repos. And what that's going to do at some point is process those documents and build out system components through the various environments into their target state. And you'll find that there'll be parameters within those documents that will allow you to target different environments, facilitate resizing a component, that type of thing. And those might be things like Terraform, CloudFormation, and Salt.
Okay, what we've just got here, we've got the scope of a traditional network architecture. So what we've got here, we've got a building, we've got the equipment in here, we've got the firewall that's protecting that cardholder data environment from the internet. Now, one thing, and I keep standing in front of this, what we've just got just here on this side, we've just got some cogs. And you'll probably see these on loads of slides coming up. And it's just a reminder for you all that you're going to have processes that are going to be involved with this as well. And then just finally, just around the outside, it's pretty self-explanatory, we've actually got that PCI DSS scope. So here we've got the diagram again, and it's showing the organization is still managing most of their computer devices in-house, but here we have, they're using this code repository that's in the cloud. And now, taking this a little step further, what we've just gone just here, we've got these engineers. So these engineers are now working remotely. And what we've got here, they've got access into the organization's network, and they've also got access to the cloud repository. So what we've got here, all of that now is going to be in scope for PCI DSS. That scope validation is going to involve regularly checking all of those relevant components and all of the personnel, so you need to be thinking about that.
Now, John's actually doing something that often happens, and he's masking the endpoints. So endpoint considerations are really vital in these environments because the way in which repos work, you've likely got copies of repos out on those endpoints where the engineers are based. So it's really important that you ensure that each of those endpoints is operating the relevant PCI DSS controls in order to prevent modification to them, which could ultimately lead to some sort of breach later down the line if you're not careful. In this diagram, what we're seeing more often is there's now a complete departure from your classical environment, and most people are storing and operating their environments entirely in the cloud. In the example here, the repo is being held likely in some sort of SaaS service, but again, you must remember that each of those components is in scope for the organization's assessment.
So one thing I just want to add here, you've got to remember here that as soon as we start talking about cloud environments, you also need to be thinking about the geography. And this is especially relevant to the assessors because certain assessors can only work in certain geographic regions. So just bear that in mind. So what we've got here, we've got some steps to that infrastructure as code. And what you're going to see here is it's very similar to that kind of traditional network architecture. So we've got setting the configuration standards, getting management approval, determining the network architecture, developing the code and the actual configuration script, and then going through the kind of change management processes, and that's also going to include the approvals and testing. And then finally, getting that, creating that device actually in production.
Now, in the engineering and deployment phases, it's really essential that you test the resulting system component, which is generated by processing the document through the engines, because IAC documents aren't very good candidates for peer review only. Remember, this is not a programming activity. You're going to end up with running configurations after the processing of the document, so those system components need to be tested. Now, make sure when you're moving to this method, you don't find yourself with very thin change records because they often get diluted because assumptions are made, oh, it's in the document. And then you've also got that habit that commentary is not found in those documents, then so they're not in the document, they're not in the change tickets, and then, worse still, someone will assert, well, the IAC document is the configuration standard itself. Well, that's self-reinforcing, so you can't make any comparison and be discriminating when you're doing your checks. So you've got to make sure you've got that really documented well, because the last thing you want is for pertinent information to only be in people's heads, which is not sustainable. So that's all something to be really careful of. But let's not forget, by using something like a repo, you are putting yourself in a really strong position for rollback, because you can use previous iterations in the repos for redeployment at speed.
Okay, and what we've just got here, we've just got a change loop that we've just added in here. So every time you're going to be going through and changing those infrastructure as code, you need to be repeating these steps. So you need to re-architecture it, you need to modify the existing code, go through that whole kind of change management process, testing processes, and then redeploy as you would in a traditional network.
Yeah, I would agree with that. You'll be looking through this during the assessment.
Right. I'll tell you what we're going to do. This isn't canned at all, so don't worry about it. We're going to put Peter on the spot. So what we're going to do, we're going to have a little bit of a scenario here, and I'm going to run through it, and then from Peter's side as a QSA, he can run through what he would actually be looking at. So what we have here, we've got an organization, and they've got a new externally facing API to transmit and process cardholder data. It's the first time they've implemented infrastructure as code, and it's the first time they're going to be implementing an API for that cardholder data processing. So the organization, they've already gone through PCI DSS assessment, everything's fine. We're not going to be touching on that. We're only focusing for this discussion just for these new systems and services. So what we're going to look at here is the focus is to identify the applicable PCI DSS requirements for that new API and the analysis of what that means for both IAC and those CDE components. So here we go. Throw this over to Peter now. First implementation we've got here, what are going to be the relevant PCI DSS requirements?
Okay, don't lynch me if you disagree. So, thank you, John. Thanks for this. I'm going to go really high level. So we're thinking firstly about IAC as a process being introduced and what that would mean to your DSS environment. So because it's infrastructure as code, you're going to be changing networking. So we know we need policy and procedure changes for requirement 1. The IAC components themselves are system components, requirement 2. It's going to be a significant change. So you know by bringing in this methodology, you need to consider how that would affect. So that needs to go in along with the access control mechanisms and methods required. So that's 7 and 8. Now those components themselves will be subject to testing and monitoring, 10 and 11. And then you're going to make a scope change because it's got to be absorbed into your scope at 12.5. And if you are using a cloud-based repo and you've not got one already, you may have to also think about 12.8. So those additions alone, just above introducing IAC as a technique, has brought change, which requires assessment activity. So whilst there's assumptions that infrastructure as code always brings speed, be mindful of that because it actually might require additional time during the assessment process.
Okay, now what you're going to do, we'll focus on those relevant PCI DSS requirements for those CDE components that in essence have been brought to life by that IAC document.
So, do you know what? There's nothing new here. It's a change of a PCI scope change, so and what would be introduced for that. So we've definitely got a requirement 1 because the network's been altered to accept new data, the 2 for the API component itself, 4 for secure traffic, 6 for the development activity and the fact that that's a significant change as well, 7 and 8 for access to the components which are forming the API, 10 to log and monitor it, 11 to test it, and finally, you're adding it to your scope, 12. The big aspect here, though, is governance, because by moving to this, to infrastructure as code, you need to ensure that any controls around it become much more robust, which ultimately is a benefit to your compliance activities anyway. The other consideration that you could think about here is this change significant enough to be classed as a full assessment or a partial assessment? But I can say right now, that's a compliance question. So go and talk to the brands or your compliance accepting entities. They'll be able to decide that with you.
So it seems, that the intro of these kind of infrastructure as code documents, they're now being absorbed into the scope and the controls in place for any future management of the IAC?
You can keep going with it now.
Yeah. Okay, so Peter, anything else that, from your perspective, you will consider from clients, in such a situation? You touched on about, a cloud repo. So is that going to be service providers?
Yeah, so scope really is always a major consideration with this type of thing, because as we saw with the example, you've got the new system components themselves have been added to the in-scope environment, the repos, any automation that goes with it, and you need to secure them. Access control will almost certainly be affected because anything that was previously done through manual configuration methods, you don't want them to be fighting with anything that's been done by the infrastructure as code processes, the engine doing its job. So it's really important that you've got that down to make sure the operational state and security of those configurations and components aren't actually battling against each other. Now, any introduction of your cloud-based repo may inadvertently expand the scope such that you've got a new service provider in the cloud, which could impact security, along with those endpoints which are making use of those repos. So you've got to be really mindful of that and how they are working and what their procedures are with it. So be mindful of all this, and if you do want to increase the amount of infrastructure as code that's in use and the amount of engineers which are making use of it, you'll need to address those system configs, your policies and procedures. But do you know what? It's all very, very manageable.
So the other thing here is this going to be a significant change?
It is. So under your traditional hard-based environment, lots of parties would traditionally have been involved with things like procuring equipment, racking it, deploying it, configuring it, and there'll be procedures that will have gone with that are quite well trodden. With infrastructure as code deployments, a new component being brought to life could be a single document. So it's quite easy for that to happen. So it's essential that any change mechanisms which you're operating become a lot more aware and sensitive of processing a document within IAC. Because what you don't want to do is make sure your scope changes and you are unaware of it. So be sensitive to them. So On top of that, it's relatively easy because of the simplicity of the documents all starting to look pretty similar. It's relatively easy for your significant change mechanism, the detection of the significant change to really suffer because you might miss the cumulative effect of various documents when they come together, which now triggers, that's a significant change for my environment. So when you combine that with things like lightweight document commenting or people cutting corners with change tickets, just be really cautious that you don't contribute to a problem in the identification of significant change.
Okay, so what is the intersection? Well, the same requirements, hopefully, as you've seen as you've just been going through them, from that traditional network configurations to the infrastructure as code, they're pretty similar. So, you've still got to develop the configuration standards, create the policies and procedures, know how to manage that infrastructure as code configs, implement those configs, and the assessors are going to be reviewing all of that.
So you might be thinking, why isn't infrastructure as code in the standard? Well, actually, if you did a search, it's there once, but it's really more of a workflow technique and a mechanism for changing your actual network. So as much as it is a tool for standardization and assurance of your config, which is why it's not actually mentioned, because the DSS isn't going to tell you how to do something. So remember that the processes, the applications, and the services which enable infrastructure as code are equally in scope, and therefore you're going to need that more time to assess. So just be mindful of that if they start using it.
Okay, so governance controls, they are essential really for those infrastructure as code environments. And they help basically that infrastructure remain secure. I'm going to touch on this. It's really important. Peter's mentioned it, and your running theme, the policies and procedures of the affected elements. You really need to pay attention to them.
Now, your version control systems, your repos, are almost always present within a well-structured infrastructure as code deployment system. Make use, or certainly guide your customers to make use of the features of the repo, because they can really help. Things like the access management aspects of the repos, any workflow management that can be built into it to automate. And those automation facilities themselves, what you've got to do is work with the customer to make sure each of those elements is attributed to the relevant areas of the PCI DSS so that they can make use of them in a good way. Okay,
change control. Again, you'll probably see similar themes could be a really important aspect of that infrastructure as code. So testing. So you've got that testing, you've got that new development activities versus the kind of infrastructure document changes. That's got to be different, and you've got to have peer review of those IAC documents. This is really important, what I'm going to say now. You need to have a second tier of testing on the resulting components. That also needs to exist.
Yeah, by introducing infrastructure as code, the processing steps performed by the engine are admin actions. So it's really important that you look at access control and make sure that you haven't left any administrative access available to people, so that you haven't got that recipe for disaster when the two collide, because you might find a position where you don't really know what's running. It doesn't match your documented system configs. It's sort of in a state of flux. So think about that one step further. If you think about the repo access, who's got rights on the repo, that's the equivalent of giving somebody system admin on those components, because they'll write the documents that will get processed. So think about that in terms of the consideration of your implementations around permissions. Make sure that's compatible with the PCI DSS requirement.
Okay, some final considerations here then. So cloud deployments using infrastructure as code, they're bringing a lot of flexibility for you to have multiple environments. It's got significant benefits, but you need to make sure that those configurations are consistent. And that consistency is, a key part here. You might, when you've got physical hardware, there's actually other controls that have been in place. So the main thing here is you need to make sure that the configuration is targeting the right environment at the right time, and you've got to include those engineers, the network admins, operations, and security personnel.
Now, I've mentioned engines a couple of times, and that's because, like most systems, they themselves are subject to further development and enhancement. What we see now is that previously unchanged infrastructure as code documents, when processed through the later versions of the engines, result in a different destination state. So you can't have the assumption that it's always going to remain the same. So that's really important that you are checking the actual target environments, not just relying on a document review.
Okay, continuous security measures,
Me.
Oh, go ahead.
My bit, though.
I was going to go straight on.
So continuous security measures, regular ASV scans, penetration tests are key to maintaining any environment. When you introduce these methods, it's really essential that any triggers that would have been present prior to moving to this workflow continue to be triggered when you are using this workflow, because you want to make sure you don't miss them, which can be easily done when you're just hitting go on executing in an engine.
Okay, so the updating of the processes, one thing to, some of the historic guardrails that you might have had with the physical hardware are no longer going to be present with that infrastructure as code. So when you're executing that IAC document, it could really have a significant impact really, really quickly.
So as you transition into this model, ensuring that moving to it doesn't diminish any controls you've already worked hard in establishing in that classical infrastructure.
So make sure you've got to test those IAC deployments. You've got to do that before production, and you've got to review the actual system configuration that's being generated from it. Basically, what's happening is these systems are going to be live at the point that IAC document is being processed. So if you haven't tested, you're going to be putting that production environment at risk in like a split second. Okay, so infrastructure as code is integrating infrastructure management with that kind of automated, consistent, and scalable methods. And PCI DSS provides you with that, the controls for the infrastructure. And that applies to whether it's being hardware-based or it's going to be that kind of cloud-based. And those controls are applying to all the environments.
So we all know that compliance with DSS is going to protect the security and the integrity of the cardholder data. And it's important that infrastructure as code doesn't erode that hard work. The documented scope information in PCI requirement 12.5 is a fantastic resource in understanding how well an entity has brought in infrastructure as code with the relevant changes that would have been seen in that scoping document. So that's a great resource. Requirement 6.5 and change processes, as I've said, need to become much more sensitive to the changes that might be introduced, whether it's a regular change or it's now deemed significant. Using this methodology is rarely going to shorten your assessment time because you've got more to actually check. And you need to reflect that when you are working with your clients. And again, just to reiterate, in your architecture and engineering purposes and how you're using it, please don't use it as a red herring to cut corners. You need to check the running system component directly. It's not a programming activity to build an application. It's bringing a system component to life, and you must continue to review the actual system component.
Okay, so if you've got any questions for either Peter or myself, we're going to be around for the next couple of days. Just one final thing, just want to mention, just as I literally finish up here, I've gone over a little bit on time, apologies for that. But one of the things is we've actually got a special interest group document, which is that PCI DSS Scoping and Segmentation Guidance for Modern Network Architectures. You can get that from our document library. Why am I saying that? There's actually a section in there that actually talks about infrastructure as code. It's a really useful document, so I highly encourage you to download and have a look at that. So, thank you very much for your time today, and please enjoy the rest of the conference. Thank you.